Hello, my name is Carson Warren with Tool Legit. Welcome to the shop. Today I would like to just do a run through of how we make some of our products, and that product today would be these wall hanging hardwood trivets. As you can see, I've got a couple designs here, one here of a wolf, one here of a bear, a couple more. I've got a salmon as well as a halibut. And to start off, we begin with our just rough stock that we need to get this to the correct width that will fit inside of our jig. What this is that we're looking at here is natural maple hardwood, and it has 3 finished sides on it. It has this surface, the face, this edge, another face, but then it has one rough edge here that we're going to be removing. All right, so I think we're all ready to make our cut. I'm going to go ahead and turn on the vacuum cleaner, and we're going to get this thing going. Okay, so now we're going to be moving over to the machine. So if you're not familiar, this is a CNC machine, a computer numerically controlled machine. Basically, it's a fancy way of saying it's a computerized router. So what we're looking at here is actually the jig that I mentioned before. So what it does is it allows us to index the material that we're going to be putting on here so that the machine knows where that material is and it can make accurate cuts. I have 6 different grooves here so that I can do 6 of these boards at a time, but for today and for our demonstration, we're just going to be sticking with one. I'm going to be drawing a vacuum through our tabletop, which is called a spoil board, and that vacuum is going to be sucking our material down flat to the table, and this allows us to make our cuts without screws or clamps, and it really helps to make a more accurate product as well, because the vacuum pressure is so strong that with some of our products that we have, it pulls the material down flat and ensures extremely consistent engraving. Set it inside of our jig, and then my lovely assistant will turn the vacuum system on. And now our product is locked into place. It's not going to move on us. There's no funny business. It does now lift up. So that is how we're going to secure that to the table. We need to get over into the software and decide what shapes we want to cut out and then put that onto the computer that does the cutting.
Okay, so I've opened up Vectric VCarve Pro, and I'm just selecting the different animal shapes that I'd like to cut out for the trivets and assigning the toolpaths for them.
Okay, so now that that is done, I'm just going to go ahead and catch you up on what took place. We actually are going to have 3 separate files that we're going to be putting onto the computer to do this cut. The first file that we're going to be doing is we're going to be actually taking this piece of MDF. This is a very special piece of MDF, and I use this to tell the machine exactly how thick to make this product. And then we are going to surface this material so that it's the exact same thickness as this material. Then what we're going to do is we're going to cut holes in the back side, and then we're going to be following up with a keyhole bit, which will allow you to place that item and hang it on a hook. We're going to then flip the product over onto its other side, and we're going to do the round over, the engraving, and then the profile that'll actually cut it free from the stock and allow us to do the final sanding that's required and final finishing. We're going to get those files onto a flash drive and get it onto our cutting computer. Another very important step is making sure the machine is zeroed. So there are some sensors that alert the machine when it gets close to its limits. The last thing you'd want is this machine to slam into the limits. It could do some damage. So what you do when you first start the machine up is you need to zero the front corner, and then once that's done, I also need to warm up the spindle and let it get to its operating temperature before we really start to tax it with removing this heavy material and doing our cut files. So we're going to get it close to those 0 points. So right now what's going on is it's finding its high limits. So the sensor triggered for the Z-axis, and now we are finding our other axes, our X and our Y. And so at this point, the machine knows this is as far as I can go in these directions. I'm gonna do a spindle warm up and let this thing get to operating temperatures before we proceed. That was about 5 minutes of a bit spinning and making a lot of noise and really nothing very exciting to see. I'm gonna go ahead and get changed over to a 1/4" end mill now. We're changed over to a 1/4" end mill, and now we need to tell the machine exactly where this corner is. And we're going to use a touch plate for that. When the bit strikes this or touches the edges, it's going to know it made contact because it completes a circuit, and it will tell the computer that that's the coordinate it needs to be at. So I'm going to start up my vacuum system, get this roughly to the center of the touch plate, and then we will just tell the computer to start. So now it's going to peck for the Z height and find it right there. It's going to do our Y-axis. Okay, it's found its Y. And now we're going to do our X-axis, which is our left and right. But now we need to level the machine off to that height of that MDF board that we were dealing with earlier. It's not going to fit inside of this like the 1/4" end mill did. So we have a workaround for that. Okay, so now we have that large 3-inch fly cutter installed, but only loosely. And there's a reason for that. I am going to lower it down to my material, let the bit rest on top of the surface of the material I'm trying to emulate, and now I can tighten it down and force the machine to believe that this is now our new surface. We are ready to run that surfacing file. And normally I would put my dust shroud on so that I keep a nice clean workspace. But for your video enjoyment purposes, I am going to forego this so that you can actually see that bit spinning and it's not obstructed by the bristles here. Okay, so we've got the file loaded and we're ready to go. Okay, so even as well as you can see, even with dust collection on, while I didn't have that guard or dust boot on there, it made quite a mess. I don't know that the video really gives it, well, credit is how much mess it made. I'm going to go ahead and just move this over and show you. I don't like to do this, but we're just going to blow this dust kind of off so that we can make sure that we get a good sealing surface when we do the remainder of our cuts with that vacuum hold down. So bear with me, I'm going to blow this off. So the surfacing is now done, and we are ready to move on to those keyholes I had mentioned before. So if you were confused, that would be this here. I have to make a pilot hole here, and then I transition to another bit, and I'll show you that here momentarily. And that will plunge into that hole, go forward, come back out, and exit out the exact hole that it entered into, so that you have that negative relief that you can hang on a screw. And we need to get an end mill, a 1/4" end mill back in there. After every bit change, it's imperative that you reset that Z height, because when I had that other bit in here, this monster bit here, it would have been in the collet at a different height than potentially this bit. So while we don't have to change our X and our Y from this coordinate, we do have to, every bit change, re-zero the height. We're going to go ahead and do that now. above the area that I want to zero. And everything looks good. It is sucked down to the table, and we are going to go ahead and do a Z height change. And we're going to get this file going. We are going to go ahead and change over to that keyhole bit. Now, full disclosure, this is probably my least favorite bit that I have in my arsenal. And here it is, maybe a little hard to see here. It's very fragile, and it's very, very sensitive to the speeds, the RPMs that your machine runs. This machine is capable of running anywhere from 1,000 RPM to 24,000 RPM. So the speed in which it travels through the material, as well as RPM that the bit is spinning in the material, they all play a very big role into the longevity of this bit. Also, big consideration with a keyhole bit is vibrations. Micro vibrations will snap these bits off, and I have broken more of these bits than I would care to admit. We're ready to fire off this keyhole toolpath. So now what we need to do is flip our stock over and change out our bit to a round over bit. And we need to do a bit change. So this bit that we're going to be using here provides a round over for the edge of the material. And as you can see here, it has a 1/4 inch round over. Okay, now I need to open up the file for this project. Now we need to change bits over to our V bit. As you can see, this is the bit here. This is going to be the most time-consuming cut on this file.
Okay, so now we have the 90-degree V-bit carving out the engravings for the different animals, and it did take about 45 minutes to get these 9 trivets cut out. So, like I said before, this is about the longest cut path for this job.
Okay, so let's take a quick look at some of these. I'd say they look pretty good. We're ready to do our final cut. This is going to produce quite a bit of sawdust.
This clip is really showing what it looks like when we do these profile passes to remove these products from the board. I'm using a 1/4 inch end mill that is an upcut, so that means that the chips are being forced in an upward and outward direction away from the product, even though a lot of chips still remain down in the board itself. The geometry is set to where it's supposed to pull those chips out, and it's taking about a 1/4 inch depth pass each time, and so it takes 3 to 4 passes, and these trivets are freed from the stock and ready to go off for sanding and finishing.
A lot of chips were made. So I'm gonna get this vacuumed off or blown off. All right, let's see if they cut all the way through. This is straight off the machine here. And now we need to start getting our branding iron heated. And we do that with a brand that we had made. The way we like to do this is instead of heating it up with a torch, we go ahead and use a hot plate. So I'm going to go ahead and turn this thing up all the way and set this down. We're going to take those trivets that we pulled off the machine, and as you can see, there is some areas on here that need to be sanded away. So this is a perfect time for us to take care of that sanding while our branding iron is warming up.
Okay, so now we are cleaning up the edges of the trivets with a mop sander that is mounted inside of the drill press, and I believe that is at 120 or 150 grit.
Our branding iron should be hot. Big reveal, the finish. So as you can see, these things are really going to start to come to life when we drop them in the mineral oil. Using gloves because it's kind of messy. See how they start to look. And then the way I like to do this is I kind of shake them off and then set them down on a rack to dry. This lets air get around them. And I like to put them face up so that that oil has some time to sink into those engraving areas. And then eventually here, I will come and wipe them off and they will be ready to go. So we've got a few more here. Well, there you have it. Thanks for coming along on this journey as we went from raw wood to finished product on these hardwood trivets that are made here in Alaska at Tool Legit. Again, my name is Carson, and I'm glad you came along on the journey with us. Thanks.